We've seen a number of companies adopt high-yield circular economy strategies. Why do you think this is so important? What is the value proposition and commercialization status of certain plastics conversion technologies? And maybe if you can focus on the examples within Axens about the new PET, I believe that PET recycling technology that you're currently industrializing with IFPEN and Jeplan.
Yeah, I think circularity on plastic is a must, not only because of plastic bashing and the ocean pollution problem, but I think also if we want our consumption mode to be sustainable, we have to solve this packaging issue. And today, plastics, even though a lot of efforts have been done, is not enough recycled. To take the example you were mentioning on PET, I think today only 20 PET is very widely used for packaging and for fibers also, but I think for packaging only 20 to 25% of the PET is finding its way to recycle mechanically mainly, and this is because mainly because PET is often colored in packaging, and when you have coloration, you cannot recycle it to transparent. I think it's fairly easily to understand. So we have developed together with IFPN a technology called the Rewind PET, which is a process, glycolysis-based depolymerization. Once we have depolymerized the PET, we're cleaning all these impurities, the pigment, and we have a monomer, BHET, that you can repolymerize in the process of PET. So that's a very short loop, which we have developed. And we tied with Jeplan from Japan, because this company is probably the unique in the world having real industrial experience of recycling PET fibers for many, many years and bottles in their industrial plants. So we join our forces with their industrial experience, processes capability, research and development to develop this new process, which we are currently demonstrating in their pilot plant in Japan. So it's currently under construction. It will be the demonstration will be hopefully finished by 2022, and then we will be ready. Axens would be ready for the commercialization. We hope to make a big step with that on the PET market, and we're already testing samples of lab PET recycle through end users, which are textile or packaging producers and users, because this is one of the big challenges on the industry. So I'm fairly confident that we will help to make this step with this technology.
That certainly sounds like a very promising development, and it's interesting to see how it develops even further. Unless I'm mistaken, there is also another technology you're developing called Rewind Mix. Is that right? Could you tell us a little bit more about that type of technology?
Yeah, the Rewind Mix, surely. This one is dealing with olefins, polyolefins, mainly PE and PP. And very often in the current recycling system, let's say, you don't sort all these plastics. You have a mix of them, and to that situation, one of the good solution is to use pyrolysis to convert them without sorting to a pyrolysis oil. But this oil is very variable in quality and contain a certain number of impurities. So before feeding it back to the petrochemical plant, namely the steam cracker, you have to purify it, get rid of the maybe chlorine. You may find other types of metals or silica. So we have developed a technology which is a fairly simple, but based on existing bricks we had in catalyst, which we call Rewind Mix, which will be able to treat any kind of pyrolysis oil before feeding it back to the cracker. So the model we have in mind is to feed one unit with several pyrolysis oil units, which maybe will be closer to the dispatching or sorting, collecting, let's say, center of plastics. So this technology is a few weeks to be put on the market, and we also think that we can retrofit some existing units in the petrochemical complex to implement it. And with the second brick, we hope also to make a contribution to the chain which is organizing in recycling of plastics.